Good afternoon, everybody. Thank you for joining me today, whether you're watching live or you're watching the recording. I appreciate you watching. Thanks for joining me. So last week we started talking about loops, and we talked about them in contrast with recursion. So we started out discussing recursion, trying to make sure everybody understood recursion, and then put that in perspective with iteration, which is what a loop is. Right? And we started looking at while loops. And so if you want to go back and review that material on recursion and iteration and while loops, I encourage you all to go back and watch the recording of the live class from last week. And this week our primary focus is going to be the for loop. And so last week we talked about the while loop. We'll do an example of we'll refresh our memories about a while loop here in just a moment. And then we'll get into talking about a for loop. So what do we know so far? What do we know so far about these while loops? So the loops that we've written so far have several elements in common, right? They have a handful of things in common. They start by initializing a variable. They have a condition that depends on that variable. And then inside the loop, they do something to update that variable. So if we take this and we get into a replet, for example, and we try to represent this. We could write a public static void method that is for a while loop. And we said we had these three things, right? We start by initializing a variable. So we could say something like x equals 1. So we just have a variable with a value. Then we need a condition that depends on that variable. So we could say something like while x is less than or equal to 10. Right? And we said our while statement last week was like an if statement. It was like a conditional statement. Just we changed the language in terms of how we talk about it. Whereas an if statement is if this is true, the while statement is as long as this is true. Then our loop does some things. So we can system.out.println x. And then finally it does that third thing that we talk about, which was update that value of that variable that we initialized there. So that'd be x++. Right, and so if we run that, we'll need to declare our we'll need to invoke our function here in main to run that. But if we run that, we see what happens, right? We get just this is a simple countdown. Or count up in this case. Right? But it could be a simple countdown if we just changed a few values around, right? Instead of starting at 1, we'd start at 10, and then we'd say, well, as long as this is greater than or equal to 1, or, 1, then instead of x++, we would x minus minus, right? We're still doing those three things. We're initializing a variable. We have a condition that depends on that variable, and we are incrementing that variable to move it toward a state where that condition is broken. And so this would take that logic that we just did, flip it around, count down instead of count up. And so just as a reminder, one of the ways that I like to talk about this is in terms of like a starting line and a finishing line, right? Like we're running a race. So we have a starting line. We have a finish line. And so our start line is our initialization of a variable here. In this case, integer of x equals 10. That is our starting line. Our condition is our finish line. When that condition is broken, we know we've reached the end, right? When it's no longer true, we know we've reached the end. And our incrementation, which in this case is our x plus plus or our x minus minus. Remember, plus plus and minus minus, they're just shorthands for saying x equals x plus 1 or x equals x minus 1, respectively. And so that just gives us an incrementation value that takes us a specified number of steps toward the finish to break our condition. And each step that we take is one process through our iteration. But we've done this a lot, right? We've actually done this a lot. That's one of the things that we've recognized here, is that we do this a lot. So since we do this a lot, or have done this a lot in the past, we had to find a way to do things more efficiently. And so that's when we invented the for loop, right? One of the things to remember, one of the kind of through lines that we always talk about when it comes to programming and development is that programmers are a little bit lazy, right? So since programmers are a little bit lazy, if there's something they can automate, or if there's something they can do easier or something of that nature, they will. Right? So in this case, we wanted to take and simplify the expression for the while loop, and so we came up with the for loop. The for loop takes all of the conditions and expressions required for a while loop and just condenses them down. So the for loop is often easier to read because it puts all of the loop-related statements in one line at the top of the loop. And so what exactly does that mean? Well, let's have a look at an example here. And then we'll go back to our replit and we will compare to what we have in there. Right, so in this instance, what we're doing here is we just, we have a program here that's printing out two what's it doing here? Just for each number through the incrementation, we're printing the number, concatenating it with a space, and giving it a power, some sort of power value, and then we're multiplying that power by 2. And so in this case, if I is 0, power is 1. We have some unknown value n here in our loop condition statement. We can assume that it was defined somewhere else, or maybe defined by a user. When we see here, what we have here is for int I equals 0. That's our initialization of a variable. So this is where we are declaring and initializing a loop control variable for our for loop. Then we have our continuation condition. That finish line that we were just talking about. The condition that when we break this condition, when this condition is no longer true, this loop will stop running. And then we have that incrementation, or conversely decrementation. just the ability to move that loop control variable toward the finish line. So since we have this incrementation here in our document, or in our for loop line here, that means we don't have to worry about reassigning the value of that variable at any other point in our program. Makes things nice and easy for us. So if we compare that to what we just did here with this while loop, we can. So let's do a public static void for loop. And we'll write something that does the exact same thing. We'll write something that does the countdown from 10 to 1, except in this case, we'll do it with a for loop instead of a while loop. All right, so we start here with our loop term, which is for. And we'll add our parentheses. Now we want to first initialize our variable. So say int x equals 10, semicolon. Include our condition. X is greater than or equal to 1. And add our movement. In this case, our decrementation. X minus minus. And then inside of our loop here, we can put what we want to do. In this case, it's just to print out system.out.print line x. Right, so let's look at these two functions here and let's map them. Let's try to zoom in here. I'm going to try to, can we keep everything kind of on the screen here? We can. So let's map everything out from our while loop into our for loop. And so we can see here, right, int x equals 10. In our while loop is the same as int x equals 10 here in our for loop. And so we can draw a line between those two. That's basically the exact same thing. Our x is greater than or equal to 1 here. Our second statement in our for loop is equivalent to the presence of that condition here. And so we can draw a line between those two. And then our decrementation here is the same as our decrementation here. So we can draw a line between those two. And we can see the relationship visually here between our while loop and our for loop. And so it's essentially the exact same thing. Right? We've just kind of rearranged the pieces a little bit. Right? All the pieces are still there. We've just rearranged them a little bit. Right, we can see our little statement here. It's all there, right? Now there is one difference that is a key difference between our while loop here and our for loop here. And it is potentially the difference that would help you decide when to use a while loop and when to use a for loop. And that has to do with the placement of this particular item, the variable that we're using here. Right, note the location of the variable. In our while loop, the variable that we've created to be our starting line for our loop, to be the starting point, that is what the condition here depends on, is separate from the loop. It is outside of the loop. Which means that x down here, if I were to refer to it, would be the same as x right here, right? It's just a regular variable. But when we move a variable inside of a for condition like this, and say for int x equals 10, we've changed the scoping for this variable. Right? So now, my program only knows what x is while it is inside of the for loop. If I were to reference x outside of the for loop here in this function, it would have no idea what I was talking about. All right, so let's watch our for loop execute here, because I did forget to change that. So let's watch our for loop execute. And we see 10.98765432.1. But if I try to say system.out.println x down here below my for loop, right outside of my for loop, we see no squiggle. So when we run this, we see we get an error status, and it's because it doesn't know what x is in this context, because this x only works inside of this for loop. And so that's the big key difference between our while loop and our for loop. If I were to try to use x, say, here, system.out.println x, and run our while loop function, we can expect it to print out the value 1 twice. It's upset at me because I forgot a semicolon. Let's add that semicolon back in there. Or it actually prints 0. Yeah, it doesn't print 1 twice, because it still decrements. It still decrements that last time, even though it doesn't print it out, because it breaks the loop. So it's going to print out that 0. Otherwise, it just stops when it gets to 1. Right? So we can see that the way x is handled here is different between the while loop and the for loop, and this is really the big reason why you choose one or the other. Right? If you're going to need to use this value later on, use the while loop. If you only need to use that value for your iteration, you can use the for loop. So let me see here. Let's do a little example, shall we? We've got plenty of time for an example today, and we can talk about some other stuff. When we get into our next module, when we talk about arrays, we'll talk about another type of for loop, which is called an enhanced for loop. But we've got all kinds of different stuff that we can talk about here. And you know, one of the things that I normally talk about, which might be a good idea to talk about here, one of the things that I normally talk about when I talk about loops is I talk about string manipulation with loops. So I think that's a good idea here. I think I'd like to talk about string manipulation for the remainder of our, or for the majority of the remainder of our class session here. We will still be utilizing for loops over and over and over again while we're talking about string manipulation. But it'll put them in a little bit of a different context, right? So let's start talking about string manipulation. So when we're talking about string manipulation, what are we talking about? Well, let's talk about what we know so far. Right, we know what a string is. It's something that we've talked about in the past. We said a string is basically just, like, you can think about it like a banner at a party, if you've seen those party banners where, there's a big, there's a long string hanging on the wall. There's a bunch of individual characters hanging on that string. We can kind of think about a string, for our purposes, in the exact same way. Right? It's just a string that's holding characters. So it's just a sequence of characters, a series of characters that makes up a word or phrase. Our computer doesn't know the word or phrase. When we read the word or phrase, that's what really prescribes that some meaning. But our computer doesn't know what that meaning is, right? So there is that. And when we see a sequence of characters surrounded by quotes in Java, we know that that's a string. And we can define a string in one of two ways, right? In general, you can use the primitive method, but we've been trying to use the constructor/object method to declare strings, which is our secondary one here. String, new string equals new string, whatever. Whatever we want to call it. So we know what strings are. What is string manipulation? Well, we can use strings on their own, or by using string manipulation, we can use the information from strings to manipulate other parts of the program. So let's look at some different ways that we can do that. And one of the first things that we'll want to know is how long a string is. And that's going to help us out when we're thinking about how we can use a for loop with a string. And so there is the length method. If I want to know how long a string is, if I want to know how many characters are in a particular string, I can use the length method to figure out how many characters are in my string. So if I go into a replit here, let's write a little function here that just gives us an output of number of characters. So we'll call this public static int num char actors. Yeah, we'll call it num characters string what should we call it? String message MSG, and then we will return some integer here. Right, so let's implement scanner so we can ask our user for an input of a word. So we will import java.util lowercase j java.util.scanner, and we'll declare our scanner at class level here. Public static scanner in equals new scanner on system.in. And in our main method, right, we can just write a little message that will request our user enter a word. So system.out.print, enter word. And then we can say string user underscore input equals new string in dot next line. And then we can print out the results of our return function here. So that would be system.out.println num characters user input. So right now all we have in our num characters function is a stub. So if we added message dot length as the value there, then it'll return the number of characters in whatever message has been input by the user. Right, remember that, we're using this here as kind of a proof of concept. We can put this in a variable. We could print this out directly. We could do a lot of different things here with this. We're not limited to using it in just this manner. Right, so if we run this, we're going to get asked to enter a word. Let's take the word computer. Computer. And so we should know what to expect with this, right? COMPUTER. 8 characters. And we get an 8 back, right? So it counted the characters. So what is the value of being able to do this? What is the value of being able to return this number of characters? Let's take a smaller word here. Let's take a word like kite, K-I-T-E. It's getting to be springtime. There'll be presumably some kids out flying kites. I'm assuming some kids still do that. And there are 4 letters in kite. So what is the importance that we know that value? Well, in a string, we have different characters that make up a string. And so if we think about it in terms of our loop, right, this is the total number of characters that is in this word. And so we know that here. So we know that as a destination, there's 4 characters here that we might want to deal with. Now, another important thing to note here is how Java and other programming languages index the characters in a string. So when we count during programming, and this will be important again when we get to the point where we are working with arrays and things like that, we start counting with 0. So K here would have the index value location of 0. I would have the index value location of 1. T would have the index value location of 2. And E here would have the index value location of 3. So if we wanted to iterate over this word and look at every single character in this word, we could create a for loop where we start at 0 go up to the length of the word and increment by 1 each time. And that would allow us to access every single character that's in our word. So let's modify some things here so we can see that happen. Right, so let's turn this into a string function instead. Yeah, let's do that. Let's turn this into a string function instead. And instead of num characters, we'll just call it characters. We'll still take our string in, but this time let's just throw an empty string here as a stub while we can get our rest of our function written here. So we know that we can get the value of the total length of our string using the .length method that we just talked about there. Now, why that .length method is so important is because we don't necessarily always know the length of the word or words our user might enter into our program, right? It could be one word. It could be, a short word like kite or was, or something of that nature, something that's only 2, 3, 4 characters. Or it could be a super long word. Right? So we can't always predict the way our users are going to enter things. So we want it to be dynamic and varied. So we can create an integer variable for word size and set that equal to message.length. There. So now instead of printing it on the output, it'll take that value and put it into another variable called word size. And so now we can create a for loop here for int I equals 0, because we know that that's where our interpreter starts counting different characters in a string. I is less than word size. And we say less than here instead of less than or equal to, because remember that it starts counting at 0, so the last character is always going to be 1 less than the entire length of the word. And then we can just increment here I plus plus. And we can system.out.println the value that's in location message, index location I. And the index location here is determined by the square brackets. And it would actually probably be smarter for our proof of concept here if we made this a void function instead of a value function. So we'll want to go up here and edit accordingly. And actually, this is a little different because it's Java. This is one of those instances where I'm writing in too many programming languages at once, we actually don't use the square brackets here. We use a different function. We would use the char at function with the value of I, because this is Java. Yeah, I've got that in my slide deck here. We just haven't gotten there yet. Too many programming languages at the same time. So this will take, and it will just print out every index location at every character at every index location. And just to make that more clear, we can add some more context to our output here. Character at index location. Let's make sure we have a space here. I. And so now if we print this out, or if we run this program rather, whoops. Oh yeah, I changed it to be just characters instead of num characters. Just characters. So now we get to enter a word. We can enter a word like, say, kite. And it tells us character K at index location 0, character I at index location 1, character T at index location 2, character E at index location 3. Right? It lists out all the characters here, and it does all of that because we added all of that extra context to our print statement here. And so whether it's a short word or a long word, like if we said something like tree house or grapefruit, right, regardless of how long our word is, doesn't matter. Since we used our message.length method here, it's going to go through and it's going to iterate through everything. Now let's do something interesting with this, right? Now we've seen this work. Let's write another function. Public, static. Let's make this one a string. And we'll call this one reverse word. And we'll bring in the string as message. So what I'd like to do, now that I know how to access each character at each index location, let's go ahead and complete our stub there. Now that I know how to access each character at each index location, I'd like to be able to use that to reverse the word. And so we can do that with a function here. So we're basically going to do the exact same thing here, but we're going to add another variable to it. And we're going to add a string variable that we're going to call reverse. And we're going to set that equal to a new string and put some quotes. Just put some empty quotes in there, no space, nothing like that. Just an empty string, just so we have an empty string object here. And so just like I counted up here, I can count down like we were doing up here. So if I were to count down, through my word, then I'd be, or do some negative index values, which is another way that we can index in reverse. I could take and concatenate a character at a time, these characters to this new string, and get a reversed string, reverse the word. Right, so what I'd want to do here might be to have another variable, integer, just to kind of hold that top number so we can use it a little bit differently. We'll call this word length. And we'll set it equal to message.length. And we're doing this because this variable value is the one that we want to manipulate. Instead of the iteration value here, we want to manipulate our word length value. So if we did something weird here, and we could actually, we could do it as a part of our for loop. So let's just do that instead. So we'll write a for int I equals message.length. But we said that our message length is always going to be one longer or one more than the actual index location of the last character, right? So we'd need to subtract 1 here from message length in order for that last character to be accurate. And so with that, we can say while I is greater than or equal to 0, because we are going all the way down to 0 in this case. And instead of I++, we do I minus. And so in this case, all I would need to do is take our value of reverse and concatenate it. So I could say plus equals the value that is at message.char at I. And then we will return reverse. And that'll take a word and return it as the inverted word for us, or the reversed word for us. So if we took this here, we took that value, and we say, made another string variable, called it user reversed, set it equal to a new string, which is the result or the return value from our function, reverse word. With user input as the argument or parameter there. And it's just reverse word instead of reversed word. Then we could print out with the console system .out.print line user input backwards is user reversed. And so that's one of the things that we can do there to manipulate our word, right? We're going through our word. We're taking each character at each index location. And we can see here, okay, if we enter word and we entered in a word like kite, we get kite backwards is etic. We would do a longer word like grapefruit. Grapefruit backwards is however you'd pronounce that. Right? Nice and easy. So we're able to use this to reverse strings. We could also use this to find, say, the character in the middle of a string. Or if there's an even number of characters, the 2 characters in the middle of a string. Or maybe we could even create a palindrome out of a word. Right? Because you can see that if I were to just take this word, take these two items and concatenate it together, then we have a created palindrome. And that is oftentimes, that would be potentially an intro beginner interview question where they might ask you, if given a word, add characters to the beginning of the word to make it a palindrome, where it's the same forwards and backwards. If it's already a palindrome, say already a palindrome. Which would be kind of interesting. And do we have enough time to do something like that? Maybe. You know what? I might do that as just a separate video and put that out at a different point. Just because I think it would be interesting. I don't necessarily think that we have enough time here to do that in our hour today. Some other interesting functions that I would like to talk about today. And I won't do examples of all of these, but I will talk about them. I might do some examples of them. Let's see. One is the compare to. Method, and the compare to method allows us to check to see if one string and another string are equivalent. And so in this instance, we have hello world dot compare to hello world in all caps. And so this should output false if we were to see something like this in a program. Let's write another public static void here and call it test string, and just do some tests in it. So if we wrote a system.out.print line and we wrote treehouse dot compare to treehouse in all caps, we would see if we call that function, and I'm going to comment a lot of this out. You can uncomment it if you like when you get the work file here. If I call the test string function now, test string, it's going to print out 32. And so that's strange, right? Like you might think that's weird. And it is a little strange. But let me tell you what it's doing, right? Because once you see what it's doing, it's going to make more sense. Now, if I took this and made them the same word, treehouse, I get the value 0. And so if they're the exact same, it returns the value 0. If it's different, it returns the difference of the ASCII values at the first letter it finds that's different. Right? So if we were to look at an ASCII table, we would find Let me grab an ASCII table and get it for us here. We would find, okay, so the first character that it encounters that's different is the T. The uppercase T value in decimal is 84. The lowercase t value in decimal is 116. If we were to do our math here, right? 2 and 3, 32 is our difference here. Right? 6 minus 4 is 2, 11 minus 8 is 3, gives us 32. So it gives us the difference between the two characters. So if it is anything greater than 0, we know the strings aren't the same, that there's something different about them. But if it's 0, then we know that the strings are the same. And so that's one thing that we can do. Another thing that we can do is use the contain method. So dot contains is a method that we can use here to see if one word contains another word. Right? So for example, system.out.println treehouse dot contains tree. So if it does, right, we get the Boolean value true. If it doesn't, right, let's say we search for kite in that word, we should expect the Boolean value false. And so I think with that, I think that's what I want to show you for today. I think that brings us to a good place. So we saw for loops. We practiced for loops while we were just getting some basic information with string manipulation. We will kind of be including string manipulation and loops and different things going forward. So of course, just like with anything else that we've discussed, we're not done with these items. Right, we'll be revisiting them in the future. But that is all that I have for you for today. If anybody has any questions, anybody who might be here with me live, if you want to go ahead and put them in the chat. If you're watching the recording and you have questions, or if you have questions later, send me an email or a Teams message and we will we'll answer them to the best of our ability. But that's all that I have for you for today. Might put out another video maybe closer to Thursday with just some more like supplemental information in it. We'll see how the week goes. That's all that I have for you for today. Thank you for watching, and we'll see you next time.